right, so I'm going to start trig equations. And um, so how to solve a trig equation? Solve the trig equation. I guess that's a terrible way of saying it. Put the trig function on one side and the value is equal on the other, right? Find the solution for one period, find all the solutions, and so that's what we're going to do here. And so, anyways, and so here if we have sine of phi or theta, I like sine of theta now. Sine of theta equals a half. Well, where's theta? So for one period, so let's just talk about what one period is. One period will be from 0 to 2 pi, not inclusive, right? So this is one period of sine, one period of cosine. So you find it for one period. And so here, so where's sine a half in our little circle? Well, the first one we know right off the top of our heads, right? It's pi over 6, or at least we'll get to the point where we know that perfectly, right? Let's go ahead and draw that real quick. This is pi over 6. This is where our first one's at. So where's the other one at? Well, it'd be on this side for sine, right? Remember, the reference angle is always with respect to x axis, and so here it'd be this. So what is this one? Well, this is 2 pi, or pi minus pi over 6, and so the other one would be pi over 5 pi over 6, okay? So here in one period, we have pi over 6 and 5 pi over 6, right? Because both of these, well, the sine is a half, right? According to our unit circle. Usually sine and cosine should, for each value you have over here, should give you two values out, right? So if we want to find all the solutions, well, here, if I travel pi over 6 degrees, I've achieved my goal. But if I also travel pi over 6 degrees and then I add 2 pi to it, I'm still at my goal. And if I add another 2 pi to it, I'm still at my goal. And so here, the answer here would be theta equals pi over 6 plus 2 pi n. And this is just a nice way of saying if I add pi over 6 to this, it's if I add pi over 2 pi to it, I'm just back at it. So I can have 2 pi, 4 pi, 8 pi, negative 16 pi. All of it works where n's a real number, or n's a natural number. Sorry, n's a natural number. And you're going to have to do this for cosine, sine, secant, and cosecant, right? These are so every time you have cosine, sine, secant, or cosecant, once you find your answers in the period, you can add pi over 6 to it. And so the same thing here, we're going to have 5 pi over 6 plus 2 pi over n. Okay. So all the solutions to the equation sine of pi or sine of theta equals a half, all the solutions are the following. It's pi over 6 plus some amount of 2 pi's, right? Because that's just a circle, right? And then 5 pi over 6 plus some amount. So here's all the solutions. And so in order to find all the solutions, this is what we're going to do. Let's do the same thing one more time with negative square root 2 over 2. So let's go ahead and do this. So the first time, so let's go ahead and look at our unit circle. It's always nice to have our unit circle. So here, square root 2 over 2 is at pi over 4. Negative square root 2 over 2 is at 3 pi over 4. Right? So here, as far as my first cosine being negative. So I'm going to write that down. So it's 3 pi over 4. And then the next time it's negative would be here. Would be at pi. So here's 3 pi over 4. Here's 4 pi over 4. So let's be 5 pi over 4. So my two ones here are 3 pi over 4 and actually let me just write it all as one this time. And 5 pi over 4. So these are my solutions in the area from 0 to 2 pi. Okay. And notice if you type this into your calculator, it's only going to give you this one. You'll have to deduce what the other one is, okay? And here you just figure out what quadrant is cosine still negative, and then you figure out what angle it is. How'd you get 5 pi over 4? Okay, so here, if I type in arc cosine, let me show you in a calculator real quick. Let me show you in a calculator what the calculator actually give you, and then what actually to do from there. Get my keyboard in front of me. And so if I type in arc cosine of negative SQRT of 2, I hope that's how you type it in here. You'll tell me in a second. Yep, so minus. So that gives me this one, right? So the arc cosine of this is 3 pi over 4, which is this angle right here, right? So cosine, but we want to find all the angles in 2 pi, or from 0 to 2 pi, right? We want to find all of them here, and then we're going to repeat that for 2 pi after that, okay? So once we find the first one, we want to find also where cosine is negative, because these numbers will repeat, right? If you remember what cosine looks like, let's look at a graph of cosine real quick, cosine of x. Let me type in y equals, nope, here it goes. So here, remember, cosine, so any value of cosine, you see that it crosses the graph twice, right? So here, if it was like 0.5, so here I have two values. If it was negative 0.5, here you see I have two values. And so we always will have two values for each one, except for at 1. Here at 1, we're only going to have one value during its period, and here at negative 1, we only have one value during its period. Here I'll get two zeros, though, during its period. So we need to find both. And And how do we do that? So this only gives us one of them right here. It only gives us the 3 pi over 4. From that, we need to determine what the other one is. And usually you'll either you figure out what your reference angle is here. So here the reference angle here is just pi over 4, right? And so then you figure out how to achieve that reference angle in whatever quadrant you want to be in. So here, cosine's negative in this quadrant, positive in this quadrant, this quadrant. So I took the reference angle here, which is pi over 4, and so here I want the reference angle here, because I want to be in quadrant 3 for pi over 4. So I took pi and added pi over 4, and that gives me this. Here, let's do this. Sine is positive here and here, negative here and here. So I knew that once I got this one, right? Once I got pi over 6, right? This is reference angle. I wanted the same reference angle here. So here I took pi, which I know this angle to be, and minus pi over 6 from it, and I get 5 pi over 6. It's the same so the same is true for sine, cosine. So right now we're just doing cosine, sine, secant, and cosecant. All these should have two answers, right? There will always be two answers except if it's negative 1 over 1. In that case, there's only one answer. We'll get into tangent and cotangent in a second, okay? All right, so here we get this, and then if we want to find all solutions, we're just going to add 3 pi. So we're just going to add 2 pi over 2 pi n to each of these, and this gives us all our solutions. Okay. All right. All right, so let's do another one. Let's say we have solve cosine of this, and so now we're just going to like, well, I don't know what that is, right? Okay, so let's just do this. So the first thing we want to do is we want to type in theta equals the arc cosine of 0.65. So let's just do that. Let's just do that live. What are we at? No, that's definitely not what I wanted open. Okay. It's going to be that way to me today. There it goes. All right, so we're typing arc cosine of 0. Not 0.65. Yeah. So I get 0.8. So I get 0.86, and so I'm about here, right? Or roughly, if you wanted in degrees, is 4.9.6. But let's stay with radians for now. Oops, let's go ahead and do that. 0.86, and so this is our cosine of 0.86. This is 0.86. Oops, I'm on the wrong screen up here. Why? I can't see anybody. Hold on. Oh, it's gonna be that way. There we go. Now I can see everything. There we are. Okay, so now we're back to here. So I'm just gonna add to, and then here, hold on. So we get one answer. So there's this answer. Well, this answer is here, as we saw. And so remember, cosine is negative, negative here, positive, positive here. So how am I going to find this reference angle? Well, I'm just going to take this angle and if I take this angle and I minus, if I take 2 pi minus that angle, right, which in this case is 0.86, right, that should give me, take me all the way around to here and then back me up to this point, okay? So this should give me the same reference angle. So this case, we're going to take 2 pi minus that. And that's going to give me 5.42. Okay, and so then to finish this, we have both our angles. We're going to just hit 0.86. We're going to add 2 pi n, and then we're going to add our 5.42 plus 2 pi n. Okay? And so here's our solution. All right, I'll leave that up for a second, and then we'll go on to the next one. All right, let's do the next set. Let's talk about tangent. Oops, in, not out. All right, let's talk about tangent real quick. Let's remind ourselves what the graph of tangent looks like for one period. So here's the graph of tangent. Oops, I don't want to write it that way. Let me put it, make it solid this way and then go. So this is minus pi over 2 to pi over 2. And then it goes in, looks like this and goes up, right? So this is one period of tangent, in case you forgot, right? So tangent equals 2. So tangent equals 2. So the period here, the length of this is 1 pi, right? So from here to here is a pi, right? Minus pi over 2 to pi over 2 is the distance we travel is pi. So this period of tangent is pi, same for cotangent. So here, if I take the arc tangent, so if I take theta equals the arc tangent of 2, I'm going to get this roughly equal, and I'm just going to save it. We type this in, roughly equal to 1.12. And in this case, since the period for this is 2, I'm going to add pi n. So I'm only adding n pi. So this is what we're going to do for tangent and cotangent. So for tangent and cotangent, let me pull up the graphs. That way it makes it very, very clear. Pull up the graphs. tangent x. Wow, right? So tangent x just goes, right? And in fact, let's type in the arctangent graph. That way we can see it real clear. That's not how you spell that. Still fix it though. So arctangent looks like this, right? It goes on for forever, right? So arctangent, the nice thing about arctangent and arccotangent is that it will definitively give you one answer. You only need to find one answer, and then you just add pi uh, pi n to it. So these, in a sense, are simpler. You just get the number, take the arc, add pi n, you're done. Okay. So these are tangent and cotangent tend to be a lot simpler in that regard. Oops. All right. So let's actually start kind of solving equations for a little bit. So here we have 2 sine minus 1 equals 0. So what do we need to do first? So here we're going to move over the negative. So we want sine by itself. So we're going to move over the negative 1. So we'll get 2 sine is equal to 1. Then we're going to divide out, oops, I got my theta. We're going to divide out the 2. So I'll have sine of theta equals 1/2. Here, as before, actually exactly as before, we'll get our 2 answers, pi over 6 and 5 pi over 6. And remember, we did this on the other page. For the 2 in a period. And then if we're looking for all the answers, we just add plus 2 pi. And so the first couple ones, just to get you used to what you're supposed to do, this is kind of the problems you'll see. I was like, okay, what do I do now? Well, here you just solve for sine theta, get it to a value, and then you do what we've been doing to get your answers. Okay. All right. So now we want to find all the solutions to this equation. Well, this one's a lot more complex. So, all right, so let's go ahead and run through this. So here, we're going to move the 3 over, so we're going to have tangent square theta is equal to 3. Then I'm going to take the square root of both sides, so tangent of theta equals plus or minus the square root of 3. So here, we'll have tangent theta equals square root of 3. We'll have tangent theta equals minus the square root of 3. That means theta here equals, well, where's tangent of theta equals the square root of 3? Why, that's just pi over 3, right? If we remember from our charts. If I type this in a calculator, take the arctangent, I'll get theta equals minus pi over 3. Just because, remember, the first period of tangent is, so here if I have square root of 3, this will occur at pi over 3, and this will occur at minus pi over 3. So we have these 2 values. Since this is tangent, to get our final solutions, we just need to add pi n to each of them. And so here, we'll just have to add with pi n, and then we're done. Okay, all right, I'll leave this up for a second, and we'll go to the next one. Okay. All right, so let's answer some a little bit more complicated ones. All right, so we want to solve the equation. So let's pretend I give you something pretty ugly. So this, right? We'd all say that this is not something you want to wake up next to, right? So how would I do this? Well, the first thing I would do is try to get cosine by itself. Well, how am I going to do that? Well, so here you have 2 cosine squared theta minus 7 cosine theta plus 3 equals to 0. Well, do you know how to simplify this? Maybe, maybe not. If I give you this, 2x squared minus 7x plus 3 equal to 0, could you simplify that? And I bet most of you, if you worked on it for a little while, could give me 2x minus 1 and x minus 3, right, is equal to 0. And if we add this up, we get 2x squared. That works out. Here I'll get 2x minus 3, which will give me negative 6. Then we get minus 7. That's what we get. And then negative 1 times negative 3 gives us positive 3. So here, if you give it enough time, you could probably figure this out. Well, we're going to do the same thing here. But instead of 2x, darn it, we have to factor that? Yeah, we have to factor that. You can always crunch it through a calculator. Calculator factor it for you. So here, since this is true, this must be true. This must be 2 cosine minus 1 of theta. Oops, hold on. I hit a button. Theta. And then cosine of theta minus 3 equals to 0. And we're going to do the same thing we would have done here. We're going to set both of them equal to 0. So I'll have 2 cosine theta minus 1 equal to 0. And then over here I'll have cosine theta minus 3 is equal to 0. Here, if I solve this out, I'll get cosine theta, or 2 cosine theta equals 1, and then we'll have cosine theta equals a half. Here, I'll get cosine theta equals 3. Well, here, cosine theta equals a half. We know that to be here at pi over 3. So here, we have it at pi over 3, because remember, cosine's positive here, negative, negative, and positive. So here we have it at pi over 3. So theta here is pi over 3. Where's the other one? Because if you type in arc cosine of a half, we'll get pi over 3. Where's the other one? Well, here, the other one's here. So how do I get this one again? Remember, that's 2 pi minus pi over 3. And that'll give me 5 pi over 3. So that's another one. And so here we'll have pi over 3 plus, since this is a sign, we'll add 2 pi n. And then since we'll add the other one, which is 5 pi over 3. And then we'll add that 2 pi n. So here's all the solutions for this half. What about this one? Here we have cosine of theta equal pi over 3. Well, can that happen? No. Cosine is between 1 and negative 1, so this will never happen. So this has no solution, right? So this has no solution. So all my solutions to this equation are right here. A random question. When does the first day of fall semester start? The 24th, I think. Yeah, I think that's right. We can look it up after this real quick. All right, so find all the solutions of this mess. Well, what are you going to do for this, right? This isn't sine or cosine or all this other stuff. But notice here, I have a cosine here and I have a cosine here, so I can factor that out. So I'll have cosine theta times 5 sine theta plus 4 is equal to 0. Once I factor that out, right? So here's another trick, you can pull out that. Either cosine theta is 0 or 5 sine theta plus 4 equals to 0. So let's go ahead and split it. So cosine theta equal to 0. Well, where's cosine theta equal to 0? Let's do that. Well, that's it. Well, that's here it's 1. Here it's 0. So here cosine 0 ones. Hold on. That's not what I'm doing. Cosine 0 here, right, at pi over 2. Then it goes here, and then it's 0 again at 3 pi over 2. So my two solutions here are pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n, over here. So this will be the cosine. So let's do the 5 sine, oops, 5 sine theta plus 4 equal to 0. Move over the 4, divide by 5. I'll get sine of theta equals 4/5, or negative 4/5. All right, if I crunch that through a calculator, it's going to give me theta. If I type in the arc cosine, or the arc sine of that, it'll give me theta is equal to minus 0.93. Okay, so let's look at our little unit circle real quick. So that's giving me this angle here. And so remember, sine is positive here and here, negative here and here. So I want this angle here. I want the same reference angle on this side. So how am I going to do that? I'm going to add pi. Instead of minusing this angle, we're going to add this angle. So the other one's going to be at pi plus 0.93. Because if I add the negative here, I'll get to here from pi. So it gives me the same reference angle. So that's roughly equal to 4.07. So this would be negative 0.93 plus 2 pi n, and then 4.07 plus 2 pi n. Okay, so here we go. So these two solutions together, so both of these together are all my solutions. So let's write it all as one thing. So I'll have pi over 2 plus 2 pi n plus 3 pi over 2 plus 2 pi n plus 0.93 plus 2 pi n plus 4.07 plus 2 pi n. So here are all the solutions to this equation. So not only are there an infinite amount of them, but there's quite a few of them.